Troubleshooting NQ-TX row lock contention weights. In the AWR top events section, NQ-TX row lock contention accounts for 0.6% of total database time. Though it's a small portion, don't underestimate it. These events prevent scalability and can grow exponentially as database activity increases. It occurs when multiple sessions attempt to update the same row simultaneously. We scroll to Segment Statistics section, and then navigate to the Segments by Row Lock Weights subsection. Here we find 24 row lock weights tied to the warehouse table. The figure 24 matches the total weight count for this event. So it's safe to conclude that all row lock contention stemmed from this table. Next, in the SQL Statistics section, a SQL statement updating the warehouse table catches my eye. Typically, the sum of %CPU and %IO for a SQL statement should roughly equal 100%, as seen in other SQL statements. But here, it's only 8.41%. This discrepancy suggests that the SQL statement was spending a significant amount of time on activities other than CPU and I/O. With a total elapsed time of 154.88 seconds, that leaves 142 seconds unexplained. The missing time aligns closely with the event's 136-second total wait time. This strongly suggests that this update cycle is the source of row lock contention. We scroll to SQL ordered by executions subsection. The same update cycle reappears again. This cycle was executed 587,069 times, but only updated 587,061 rows. So there were 8 executions did not change any rows. These 8 fruitless executions likely rolled back. We check the Instance Activity Statistics section. The user rollbacks metric shows exactly 8, perfectly matching those failed executions. Digging deeper, the NQ deadlock statistic also reports 8 deadlocks, revealing that these rollbacks were triggered by deadlock detection. We then move on to check the NQ activity subsection. In the Weight Statistics section, it reveals 24 lock requests were made, 16 succeeded, and 8 failed, consistent with the rollback count. Let's put pieces together to get a full picture of this issue in AWR report. At this point, we've laid down the SQL statement and the table involved in the NQ-TX row lock contention wait event. But can we dig further to pinpoint the specific rows experiencing the contention? Yes, we can. This is where active session history comes into play. When Ash captures NQ-TX row lock contention wait, it also records 4 related values: current object, current file, current block, and current rows. These values can be combined to generate the row ID of the affected rows. This query puts this into action. The query outputs contented rows. Among all rows, the one with the highest captured occurrence count is 4. To examine this row, we can select it with its row ID. This query returns the top contender